So let's see how can we calculate the total entropy of the surroundings. The total entropy of the surroundings system will the surroundings of the system equal to negative the delta H of the reaction over the T. So I have a reaction here, and this reaction happened in a certain system, and this reaction gives out heat to the surroundings. So what is the entropy of the surroundings after this reaction? It's equal to negative multiplied by the delta H. So the reaction is exothermic, and I'll multiply it by negative, the result will be in positive. And the value has to be in temperature in Kelvin, so it is 273 plus the Celsius degrees if it's given in Celsius, and then divided by the T. So delta S surroundings equal to negative delta H over T is equal to negative 125 over 298. Negative 125, so equal to positive value 0.419 kilojoule per Kelvin. I have to change it into joule per Kelvin by multiplying it by 1000. Okay, then what if the reaction is endothermic, like this reaction? There is delta H is equal to 778, so I created this reaction. The system reacted, and the reaction is endothermic, so heat is absorbed inside. And I want to see what happened here to the delta S of the surroundings. Oh, apparently, the delta S of the surroundings will also decrease because I have removed some heat from it. So I caused it to be less random. We'll see this by the value. This is equal to negative delta H over T, but delta H this time is 778, so it'll stay negative of the positive is still negative. And don't forget to change the T into 298. It's equal to negative 2.61 kilojoule over Kelvin. Multiply this by 1000 again to change it from the kilojoule into the joule, the unit of the S. So we have seen that how spontaneous the process is determined by the change in the entropy it produces in the universe. We also have seen that the delta S of the universe has two components, the delta S of the system and the delta S of the surroundings. So if I have for some process the delta S of the system and the delta S of the surroundings, both of them are positive. So the delta S of the system is increasing and the delta S of the surrounding is increasing. What will happen to the delta S of the universe? The delta S of the universe will be also positive. So the randomness of the system is increasing and that of the surroundings increase. The delta S of the universe equal to the total of these two together. This one plus this one, so it will increase. Okay, so the process will be spontaneous. The process itself will be spontaneous because delta S is positive. If the delta S of the system is decreasing and negative, and the delta S of the surroundings also negative. So the process does not occur in the direction indicated. So it will be non-spontaneous process. The delta S also negative plus negative is equal to negative. So the delta S of the universe will be negative and the process will not happen. But the opposite of it only can happen. If delta S of the system and delta S of the surroundings have positive signs, like one of them is plus and one of them is minus, or the delta S of the surroundings is plus and the delta S of the system is minus, then the total or the delta S of the universe will depend on what is the value of this one and what is the value of this one, because it might be plus but small value or big value, and this might be minus or small value or big value. Like how? If the delta S is small, then the delta S of the surroundings, this is plus 500 and this is minus 500, the delta S of the universe will be negative because the bigger number is negative. And if the delta S of the universe is positive and the delta S of the surroundings is negative, but it is negative value only minus 500, then the delta S of the universe will be positive. So this says that if the delta S of the system and surroundings are of positive, one is negative and the other one is negative, then it depends on what is the magnitude of every one of them. This is what will decide which one is bigger, will decide if the total delta S of the universe will be plus or minus. That's why we will know that the spontaneous reaction depend too much on what? It depends too much on the temperature. So the water, for example, can freeze below 0 degrees and melt above 0 degrees. So since we said delta S of the surroundings is equal to negative delta H over T, this means that the magnitude of delta S of surroundings will be very small at high temperature. At high temperature, it will be very small because it's inversely proportional. And this one delta S of the surroundings will decrease. And at low temperatures, the delta S of surroundings will increase. That's why we need to know the exothermic reaction is a very important driving force when the temperatures are low. So if you want the reaction to be spontaneous and the temperature is low, the reaction has to be exothermic.